Hello, my name is Abhinav, and as a part of peer assignment, I am giving my presentation for enhanced adverse drug reaction detection in pharmacovigilance using machine learning. So, first of all, I will like to talk about the problem introduction. So, the problem that I have taken is related to the pharma domain, and for this project, we are using ML for enhancement of adverse drug reaction detection in pharmacovigilance. And ADRs are harmful and unintended responses to medications, and timely detection is crucial for patient safety and public health. So why I choose this for our ML solution? Because of the data availability, the pharmacovigilance domain has a vast amount of structured and unstructured data from clinical trials, patient reports, electronic health records, and social media. So this data richness makes it an ideal candidate for machine learning application. So the impact for this will be like accuracy and timely detection of ADRs can significantly reduce patient morbidity and mortality, and prevent cost drug recalls and improve overall drug safety. So this has substantial impact implications for public health and pharmaceutical industry. The feasibility is like advances due to the advance in NLP and machine learning, which provides the tool for necessary to analyze complex data sources such as medical literature and patient reports to identify potential ADRs more effectively than traditional methods. And now I'll talk about the Christian business understanding. So the problem statement, problem definition, as I explained, the business objective is to improve the accuracy and timeliness of ADR detection to enhance patient safety and regulatory compliance. And the problem statement is like how to leverage ML to detect ADRs from various data sources more effectively than existing method. Success criteria for this will be it is defined by the ability of the ML solution to detect ADRs with high precision and recall compared to the current system or the current solutions. And this includes reducing the time to detect new ADRs and increase the number of true positive detection while minimizing false positives. So the success matrix, which will be like outcome matrix, and the output matrix will be for outcome, it will be the reduction in the time taken to identify new ADRs, increase in the number of ADRs correctly identified. Output matrix will be like precision and recall for the ADR detection model, the number of ADR cases identified per month, time to alert regulatory bodies for the new ADRs. So yeah, and the relevant factors will be which I'm going to consider is patient demographies, medication dosage and administration details, clinical trial data, EHRs and patient history, and social media and online patient forum data. uh, Now I'll talk about the solution validation plan. So the solution concept will be the proposed solution involves developing a machine learning model, specifically an NLP-based system, to analyze various data sources like EHR, clinical trial reports, and social media posts to identify potential ADRs for any particular drug. And the validation approach will be the data collection and pre-processing that data collection and preparation. So aggregate and pre-process data for EHR, clinical trials, and social medias. Annotate subset of data for training and validation process. Model development will include train and NLP model using annotation data to recognize pattern indicative for ADRs, using techniques like NER, named entity recognition, and sentiment analysis to improve detection accuracy. And for iterative testing, we'll be conducting experiment to validate models performance using cross validation and continuously refine the model based on feedback and performance metrics. Evaluation will include compare the model performance against existing ADR detection methods, access the precision recall and F1 score to determine the effectiveness. Now I'll talk about the ML system design. So the model type that we are going to use is I will be using a transformer based NLP model. It can be either a BERT or GPT due to their superior performance in understanding complex language patterns and context in medical text. For features, I will be including features like drug name, dosage, patient demography, medical history, and sentiment indicators from patient reports and social media posts. For training strategy, I'll be using the we can use transfer learning to leverage pre-trained language model and fine-tune them on domain-specific data for better performance. And the justification for this, it will be like why I'm using the transformer based model is like because it's an state of art for NLP task and have shown excellent result in various domains, be it like text generation, text summarization, Q&A. So it's given a very proper result for that. And the selection features are crucial for understanding the context and potential areas. Transfer learnings allows for efficient training and leverage existing knowledge embedded in the pre-trained models as well. So I'll talk about the potential risk in production. So possible model issues that can be like training, serving, skew. The model might perform well during training but poorly in production if there is a mismatch in data distribution. Continuously monitoring and real-time data validation can mitigate this risk. So and the next can be latency. So processing large volume of data from multiple sources in real time might introduce latency. So optimizing the model and infrastructure can address these issues. Data drift and concept drift can also happen. So change in drug usage pattern, new drug introduction, or shift in patient demographic could lead to data drift. Regularly retraining the model with updated data can help manage this risk. Biasness and fairness can also be can also happen in our production model, and the model might be biased towards certain demography or type of data. Ensuring diverse and representative training data and incorporate fairness constraint in the model designs are essential. So by addressing these issues proactively, the MS solution for ADR detection in pharmacovigilance can be robust, accurate, and reliable in production setting.